In this video, we'll take a look at a problem where we're asked to determine where a function has asymptotes from out of section 1.5. So this is problem 28 from out of this section. In class today, a lot of you were looking at 27 and 29. If you weren't quite following how you need to locate vertical and horizontal asymptotes, this should hopefully help. Before we look at anything in problem 28 specifically though, just want to kind of remind you of what we had said in class a couple days ago. A vertical asymptote is going to be at x equals a if two things happen. This is all that needed to happen for you before. F of a was undefined. I would guess that last year, if you had a function that was undefined for a given value of a, you just automatically said that x equals a is an asymptote for that type of graph. But now we need one other thing to happen, because what we've seen a little bit of this year is we've seen situations where we've had graphs that appear to be lines even when we graph them on the calculator, but if we really think about what's going on, they have these little holes poked out of them. So if this is the x value of, say, 3 right there, f of 3 is definitely undefined, indicated by the hole in the graph at that x value, but as I approach 3 from either side, my y value on this particular graph might be something like 1. So the limit as I approach 3 would be 1. It's definitely not a vertical asymptote. This isn't a line that we get closer and closer and closer to and never cross or touch. It's one little hole in the graph. So the other thing that has to happen in order to consider something the location of a vertical asymptote is you have to check the limit as x approaches this value where it's undefined, and that answer must be either infinity or negative infinity. Now this little notation right here is just to kind of denote that we're going to check it from the bigger side and from the smaller side, and I'll definitely point that out when we get to that point in problem number 28. A horizontal asymptote is going to be at y equals a if one of these two things happen. Most of the time both of these things happen, but if one of them happens, you definitely have a horizontal asymptote at the location y equals a. And there isn't anything that you have to do with the function other than jump right in and check a limit as you approach infinity. If you check the limit as you approach infinity for a function and your answer is a numerical value, a finite value, you know you have a horizontal asymptote at that finite value. The other thing that could be true is that the limit as you approach negative infinity is also a on that function. If either of these happen, you definitely have a horizontal asymptote at the value of a. Most of the time, like I said, both of them do happen simultaneously. With that said, we'll kind of go and look at how number 28 is going to shake out. So let me get a little closer here. And it doesn't really matter which ones you find first. I actually tend to find the horizontal asymptotes first. So I'm going to do my work to find horizontal asymptotes right off the bat here. And I only do this first because all I have to do is check two limits. I have to check the limit as x approaches infinity on this function. So function is x squared over 4 minus x squared. And I also want to check the limit as x approaches negative infinity on the same function. Now if I plug infinity in place of these x's, I'm looking at infinity in the numerator and 4 minus infinity in the denominator. So I'd have infinity here divided by negative infinity. And infinity divided by infinity, infinity divided by negative infinity, that's an indeterminate form. So I did consider putting this value in place of the x's and hoping I was going to get an acceptable result. Unfortunately, it gave me an indeterminate result. So I'm going to go ahead and say, well, I remember a trick we spoke about, and that trick was able to be used anytime you had a rational function, a polynomial over a polynomial, and x was going to either infinity or negative infinity. And the trick was pick the highest power of x from in your denominator, and the highest power of x from in the denominator here is an x squared, and divide every single piece of the numerator and the denominator by that power of x. So I'm dividing the x squared in the numerator by x squared. Whoops, getting a little ahead of myself there. I'm going to divide the 4 in the denominator by x squared, and I'm going to divide the x squared in the denominator by x squared. Do some simplification. These cancel. Now in class today I noticed people were canceling these, which is allowed to be done, but something divided by itself is 1. That's why we're able to cancel out both those. If you just leave that as an empty spot in your fraction, that's not likely to lead you to the right result. There's no cancellation here. These cancel, but again, something divided by itself is going to be a 1. And now if we put infinity in place of the only x that remains, what we end up with is we end up with a 1 in the numerator. We end up with 4 divided by infinity, which is going to tend to 0. And we end up with a minus 1 after that 0. So we have 0 minus 1. Well, 1 divided by 0 minus 1 is going to give us a value of negative 1. This is enough to verify that we do have a horizontal asymptote at y equals negative 1. I'll leave the calculation to you if you want to carry it out. It's going to be the same exact sequence of steps, but you will get a limit of negative 1 as you approach negative infinity on this particular function using the same exact trick, same exact technique. So this function, without a doubt, has a horizontal asymptote at y equals negative 1. Ready to transition into the vertical asymptotes. And I have a little bit of preliminary work I have to do to find the location of a vertical asymptote. I do have to figure out where the function's undefined. And this function, if we go back and look at it, I like to have it in factored form. And the denominator is a difference of squares, 2 minus x, 2 plus x. I can now think pretty easily that whenever x is 2, this factor is a 0. Whenever x is negative 2, this factor is a 0. 2 and negative 2 are the x values that make my denominator 0. Those are the candidates for vertical asymptotes. So I'm just going to kind of list them down here. I'm not going to say that we really do have vertical asymptotes at these x values until we verify some limits. We talked about that at the beginning of the video. So I need to check the limit as I approach 2 on this function and the limit as I approach negative 2 on this function. If I approach 2 and I just try to plug into the function, which is x squared over 4 minus x squared, what I'm going to end up with is I'm going to end up with, in my numerator, a 4, and in my denominator, a 4 minus 2 squared, 4 minus 4, or 0. So that's undefined. It's not indeterminate. It means our answer is likely either infinity or negative infinity. To find out which, we need to think a little bit more carefully about which side of 2 we're on. So I'm going to approach 2 from the bigger side. And I'm going to go back to the factored form of this denominator. So I had this written up above. I'm just going to bring it down here now. You don't have to deal with this in factored form. I kind of find it a little bit easier to do that though. And I also want to check the limit as x approaches 2 from the smaller side on this function. And again, I'm going to deal with the factored form of the denominator. Oops. I don't have an issue with ending up with a 4 in my numerator. Totally okay with that. So I'm just going to copy that down. I don't really have to be careful about which side of 2 I'm on in the numerator. 4 in a numerator is fine. In the denominator, I don't have to worry about this second factor, right? 2 plus 2 is 4. It's okay to have a 4 in the denominator. The thing that's not okay is to have a 0 in the denominator. And if you put 2 in place of this x, 2 minus 2 is 0. You can't have division by 0. So this is the one that I really have to be more careful with. I needed to really determine which side of 0 I'm on in this denominator. So if I put a number slightly bigger than 2 right here, a number like 2.1, and I do 2 minus 2.1, I realize I'm going to get a number that is very close to 0, but it is going to be negative. So I have 0 from the smaller side there. Now I'm just going to simplify. 0 times 4 is 0. But which side of 0 are we on? Well, it's a negative times a positive, so that's still negative. So we have 4 divided by a negative 0. And a positive value divided by a negative value is clearly going to give us a negative result. And 4 divided by 0 is going to give us a very large value. So we get negative infinity for that limit as we approach 2 from the bigger side. As we approach 2 from the smaller side, similar thing's going to happen. I don't have to really be careful with that piece or that piece. I have to be careful with this first factor in the denominator. 2 from the smaller side, a number like 1.99 goes in place of this x. And I do 2 minus that value. I'm looking at a value that is very close to 0, but on the plus side is 0, on the positive side is 0. Just like we did before, 0 times 4 is 0. Positive times a positive, though, now this is positive. 4 divided by 0 is a big answer, and a positive divided by a positive is a positive answer. So one of these things happening as we approach 2 from either side is enough to verify x equals 2 as a vertical asymptote. Normally, you're going to have infinity and or negative infinity on both sides. So we definitely have determined we have a vertical asymptote at x equals 2. Now this limit doesn't exist, and that's okay. We know we have a vertical asymptote there because these were not equal to each other. This original limit doesn't exist. My fault. We know we have a vertical asymptote here because these were infinity or negative infinity. We know this doesn't exist because these two were not equal to each other. You could go through the same sequence to determine that you do have a vertical asymptote at -2. You should get infinity or negative infinity when you carefully check the limit on either side of -2, similar to how we did this. But that's how you verify the location of a vertical asymptote. So horizontal, just dive right in with the limits. You're approaching infinity or negative infinity. If you get a numerical result, you know you have a horizontal asymptote at that numerical result. For vertical asymptotes, a couple things have to happen. You have to be undefined there, and then you have to have an answer of infinity or negative infinity for the one-sided limits as you approach that x value. Since this is already getting a little lengthy, I'm going to skip the -2 part of this, but hopefully this helped. If you have any questions, please feel free to come on by and ask.